Okay, so 0 and negative exponents. That's what we're going to be working on today. Just making sure we review what we did in class. So one thing I really want to emphasize is the relationship between division and multiplication. So let's remember that dividing by 2 is the same thing as multiplying by 1/2. Because when you divide by 2, what do you get? Sure enough, you get, excuse me, I thought I had my pen, but obviously not. You get 5. And 10 times 1/2 is also 5. So dividing by 2 is the same thing as multiplying by 1/2. So please just keep that in mind as we go along. Same thing if you're going to divide by 3. It's the same thing as multiplying by 1/3. And 18 divided by 3 is 6. And 18 times 1/3, or 1/3 of 18, is also going to be 6. How about dividing by 5? Well, it's going to be the same as multiplying by ... You got it? You got it? What's it going to be? Multiplying by 1/5. 35 divided by 5 is 7. And 35 times 1/5 is also 7. So just please keep that in mind. So we're going to look at tables illustrating patterns of exponents with a base of 2. Please pay close attention to the row with a 0 exponent. What does that look like? And how about rows when there's a negative exponent? What does that expanded form and simplified form look like? All the while making sure you remember multiplying by 1/2 is the same as dividing by 2. Oh, it changed color on me. So if I have 2 cubed, it's the same as 2 times 2 times 2, which you all know is 8, thanks to looking for Pythagoras. Next, 2 squared is 2 times 2, which is 4. 2 to the first is 2, which is 2. So notice each time in this simplified column, we're going from 8 to 4, 4 to 2. You can think of it as dividing by 2 or multiplying by 1/2. And when we do exponential functions, which you're going to get to in algebra, probably not to algebra 2, you want to think of, rather than dividing by 2, you want to think of it as multiplying by 1/2. Well, look what happens here. 2 raised to the 0 power. That equals 1. And 2 divided by 2 is also 1. So if we continue on the pattern, that makes sense. But we're also going to want to learn why that works. And it's really cool why. And we're going to show you that in another day or two. So it's not just one of those magical things that happens that sometimes people think math is magical. It's not. There's a reason. When I go to 2 to the negative 1, it just becomes 1 over 2. Once again, I continue to multiply by 1/2 or divide by 2. So 2 to the negative 2 is 1 over 2 squared, which is 1 over 2 times 2, or 1/4. 2 to the negative 3 is 1 over 2 cubed, which is 1 over 2 times 2 times 2, which is 1/8. Each time, as my exponents go down, I keep multiplying by 1/2 or dividing by 2. Notice, negative exponent does not mean a negative number. It's really important that you understand that. So let's go to base 10. Base 10 is going to be very helpful. It's understanding exponents of base 10, because that's our number system is a base 10 system, and we get into really big and really small numbers. Scientific notation, you're going to want to know your powers of 10. So 10 cubed, 10 times 10 times 10, 1,000. 10 squared, 10 times 10, 100. 10 to the first, 10, 10. 10 to the 0, here we go again, it's 1. Following that same pattern as we did on the simplified version of with a base of 2. 1,000 times 1/10 is 100. 100 times 1/10 is 10. 10 times 1/10 is 1. And as we keep going, those negative exponents, we continue to multiply by 1/10, which is the same as dividing by 10. Once again, notice, Negative exponents, not negative answers. So what I want you to do is the base 5 table is in your packet. Go ahead and fill that in. Turn off the video and then come back and we'll make sure you have it filled in correctly. So hopefully you have turned it off, and now we're going to continue. So we have 5 cubed is 5 times 5 times 5, and you guys all know that's 125. Thanks to looking for Pythagoras. 5 squared is 5 times 5, 25. 5 to the first is 5, which is 5. 5 to the 0, it's 1, which simplifies to 1. 5 to the negative 1 is 1/5. 5 to the negative 2 is 1 over 5 squared, or 1 over 5 times 5, which is 1/25. And 1 over 5 to the negative 3 is 1 over 5 times 1 over 5 cubed, I should say, which is 1 over 5 times 5 times 5, which is 125th. Shh, quiet, please. All right, so let's look at a formative assessment. Nothing fancy here, folks. Just making sure we understand. And you might not understand why at this point, but we're going to get there. So 3 to the 0 is 1. 17 to the 0. What do you have? 1. 8 to the 0. 1. 11 to the 0. 1. X to the 0 is 1. Well, now let's work on writing expressions that have a negative exponent, writing them with positive exponents. So this just becomes 1 over 4 to the 5th. This becomes 1 over 3 to the 7th. Right now we're just going to write them in exponential form. 1 over 12 to the 3rd, and 1 over 6 squared. Any number x raised to the negative 4th is 1 over x to the positive 4th. So hopefully you got those right. If there's something you're not understanding, email one of your teachers, please. So let's think about writing a rule. So anytime I have a number raised to the 0 power, what's my answer? Da 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 da, 1. You might not understand why yet, but we'll get there. So how about anytime I have a base, no matter what my base is, whether it's a number or a letter, and I raise it to a negative exponent, that just becomes 1 over my base to the n, which is a positive exponent. So 1 over a to the n. One thing I want to make sure we understand, that a negative exponent does not necessarily mean a negative number. There's a difference between 2 to the negative 1/3 and negative 2 to the 1/3. This is going to be 1 over 2 cubed, and this is going to be negative 1 over 2 cubed. So notice the negative stays up top, but the 2 and the exponent 3, right, go to the bottom. All right, that's it. I hope it wasn't too long. See you tomorrow. Sorry, I'm not quite. I can't get this to one. It's not stopping for me.